So our next presentation is from the Industrial and Manufacturing Engineering Department, and is titled Process Improvement at Casa Herrera Manufacturing Company. This study focuses on improving the processes of inventory and shipping departments in Casa Herrera, a producer of food machinery with an average annual order value of $42 million. The team's project reviewed bottlenecks that led to shipping delays, resulting in loss of revenue. The team proposed several recommendations based on time studies, data analytics, simulation, and machine learning methods to speed up shipping by at least 5%. And I invite the IME team to share the presentation, please.
All right. Good afternoon, everyone. Today we'll be presenting our project for Casa Herrera. My name is Charles Brion, and these are my colleagues.
I'm Dustin Shreve.
I'm Micah Tischler.
And I'm Roger Tran, and our advisor is Dr. Mirzai. So here we're going to first start out with the outline. We're going to first talk about the company background and the problem statement before we focus on the inventory and shipping department. And then finally, we'll summarize everything.
A little bit about the background of the company. Casa Herrera was founded in 1950. It's a local family-owned and operated business, and they focus and specialize in the manufacturing of tortilla-based machinery. Some of the companies that you may be familiar with that they've worked for are Frito-Lay and Mission Foods.
So here's just a brief overview of the entire manufacturing process. The team will be primarily focusing on the inventory and shipping department, as those are highlighted in red.
All right. Now, as an interconnected system, every department plays a critical role in the overall operations of the company. For this project, we are tasked to investigate why are some items not being shipped out on time. And again, our project is going to be focusing on the inventory and shipping departments of Casa Herrera.
Okay, so for the first department we're going to be looking at is the inventory. And then the main issue we found with that is that they have a long overall picking process, and this leads to a delay in the assembly process. So our overall objectives is to decrease the amount of time by 5%, but we want to see if we can hit a 10% goal. And then similarly, for the shipping department, we found that there's two main issues with this. The first one is that they have a lengthy crating process, and this is due to the fact that they have to custom make all these crates for each of their individual items. And also, because of that, it leads to overflow in the work area due to the amount of backlogs that they have. So similar to inventory, our goal is to decrease the crating time by 5%, but we want to see if we can hit a 10% goal. So now we're going to go a little more in detail to the inventory. So like I mentioned earlier, they have a long picking process time. So it takes them average about 3 hours to finish the picking, but of that, only 1 hour in operation. So a lot of that time is spent like moving around, or just the pick list is just sitting on his desk being ready to pick. Another issue that we found was that there's a high employee turnover rate. So through numerous visits, we found that there's only one consistent employee that they have, and then within a period of 6 months, they had over 3 employee turnovers. Another issue that we found was that items were being misplaced in the inventory, but that's an issue that another team will be targeting. So now you can take a look at the simulation that we created for the process. So the first step is the pick list gets generated, and then it makes its way to the picker's desk. From there, they're able to verify the location and make sure that there's no discrepancy before he starts the picking process. So the picking process consists of him going to the correct aisle, looking for the item, and picking the item. So once he does that for all the pick lists, he makes his way to the scanner, scan out all the item out of inventory, and then the items will either make its way to the staging or the assembly. And then here's just the results of our simulation. They finish about 4.5 pick lists a day, each taking about 3 hours, but only of 1 hour in operation. Now I'll pass on to Dustin to talk about some of our alternatives.
All right, so the team, the first alternative the team came up with is labeling the rows on the pick list, because currently, right now, on the pick list, it has, for looking at an item, it's based off of the aisle where the item's located, and then the column or shelf where it is. And by not having the rows on there, it's unnecessary search time and a waste of time. So through doing some time studies, we ran with with one of the pickers. We found that adding the rows saved us time, and we were able to plug into our simulation model to find the total picks completed in 18%, and the average time per pick on decreased 4%. A second alternative is organizing the pick list based off of the order, because currently the way the pick lists are organized, it's based off of, there's no order to it, so the picker's making unnecessary trips back and forth across the floor. So so by ordering it, it should reduce that wasted time, and by doing so and using the simulation, we found that the total picks completed increased 5%, and the average time per pick decreased 3%. And a final alternative is labeling the rows. Is a combination of labeling the rows and organizing the pick list. By doing this, it's the best case scenario. As by combining, you get both time savings. And by doing this, the team found that the total picks completed increased 33%, and the average time per pick decreased 8%. Now I'll hand it over to Michael to talk about the shipping department.
So in the shipping department, we decided to focus primarily on crating, which is the longest process that they utilize for exits. In the crating, they focus primarily, they have one worker that they rely on, and they have no standard operating procedure at this current time, and there's a lack of space due to the backlog of items reaching shipping. Our current simulation has an output. We can see that our current simulation has some redundant steps between measuring and cutting wood and then building the crates. And then after the crates are built, they can be weighed, labeled, and they're ready to be shipped out. Our current process takes about an hour and a half to produce a crate, of which only 22 minutes is spent assembling that crate. And in an 8-hour day, they can produce about 6 1/4 crates. So we decided to come up with a couple alternatives to try and remedy our problems. The first one was pre-measuring the crates, as most of these items are built within the facility. On the bill of materials, these measurements have already been taken, and so this is a redundant step. And so this can be virtually free to implement and build these crates. The throughput for crates produced and the time saved is both 6% in this case. Our second alternative was to utilize pre-manufactured crates. This is already utilized for some standardized machinery that they produce. And while these are, as we can see, they meet our criteria for exiting the system quicker and in more number, they take up more area for storage, which is something we want to relieve, and they do cost extra money to implement. Our third alternative is to establish another worker. This would reduce their reliance on that single worker that they're relying on. They could then create a standard operating procedure for the future. This would shore up that deficiency. And while it does meet both our criteria, it does take additional funding to establish this as well.
Now, to further supplement our findings, our group decided to utilize some machine learning, and specifically the algorithm we use is the k-nearest neighbor algorithm. So how it works is basically it looks at neighboring data points in a data set to aid itself in classification. So our model's goal is to predict the shipment type of an item based on those 4 variables. This benefits the company to have a little bit more time, right, to prepare for the upcoming shipping demand. The moment an item is picked out of inventory, they have some sort of idea of how this item is going to be leaving the facility. To further improve our model, we conducted some parameter tuning to find the optimum K value. So again, the K value is just basically how many other data points should our model look at before we decide on what's this shipment type. And we eventually found an optimum K value at 49, and at that K value, our model was at an accuracy of almost 80%. Now, for our conclusion, we summarize all our findings in one table. So the first thing we had to consider before we even decide what route we should recommend to the company, we had to see if our results are even statistically valid. So we calculated the p-value at 95% confidence. And if you look closely, only the first alternative and the third alternative have a p-value less than 0.05 or 5%, meaning only those two alternatives actually have a statistical difference compared to the current process that Casa Herrera uses. We then calculated the gross profit that Casa Herrera makes based on how much profit they make for each completed pick list, and we then compared the percent improvement of that profit with what they currently have. And based on that, the third alternative, which is the combination of the first two, is the best option for them to take for inventory. Now, similarly, for shipping, we also did the same thing. We had to check if it's statistically valid. But for this one, a little better, all three alternatives have a statistical difference compared to their current process in place. We then also calculated the gross profit, and this, believe it or not, they're actually making a little bit of money selling and charging people for these crates. But from there, we continued on by finding the percent improvement in gross profit. And based on that, the first alternative is actually the better one compared to the other two that, although they have a higher amount of crates, completed, they actually cost more to implement for the company.
So for our recommendations, the team for inventory recommends that they implement the combination of both adding the rows to the pick list and then also organizing the pick list based off of order, as it gave the best with time reduction and increased number of picks. For shipping, we recommend that they use the pre-measure crates. They pre-measure crates based off the bill of materials, as they already have that resource, and compared to the other ones, it gives the best return on profit. We also recommend the shipping department utilize the predictive model, as it allows the shipping department to better prepare for items coming into shipping. And finally, for during time constraints, which the team observed, we recommend that they use the pre-made crates. However, in the long run, by using it, they will not make as much profit, or they won't make profit. And with that, acknowledgement, we'd like to thank Casa Herrera and especially those in the inventory and shipping department for giving us the time, answering our questions, and allowing us to observe and to conduct time studies. And also, we'd like to thank our advisor, Dr. Mazai, for all her feedback and guidance during this project. And with that, we'd like to say thank you for listening to our presentation.